Zero is my hero.
Welcome to the adventures of Math Girl. With the help of Pocket Ronnie, you also can become a trusty sidekick of Math Girl, like Kid Calculus and the Daring Derivative.
Counted on our fingers and toes.
Okay, we're doing more rate problems. So, in the last lesson, we had two people or two objects going the same distance. So you had a D1 and a D2, a distance 1 and a distance 2. And so since they went the same distance, then you could say D1 equals D2, and a distance is a rate times time. So we could have said R1 T1 equals R2 T2. Not R2 D2, but R2 T2. Anyway, so you can set the rate times time is equal to the rate times time. Okay, in this lesson, so again, that was two people or two objects going the same direction and going the same distance. Okay, in this lesson, we're going to have three different scenarios. Okay, in our first scenario, we're going to have two people or two objects and they go in the opposite direction. They start at one place and then they go in the opposite direction. Okay, and then they have an ending point. So one person goes in the opposite direction and has a distance. One person goes in the other direction and has a distance. Okay, in our second scenario, then we're going to have two people or two objects. One, they will go a distance for a one speed. Then they will go in the same direction, they will go another distance, maybe at a different speed, and then they have an ending point. And then in our third scenario, we're going to have people starting in opposite places and they are going to head toward each other. And they will have some sort of meeting point. You can't always assume this is in the middle. It's not in the middle. They will meet somewhere, and one of them has a distance, the other one has a distance. So in each of these scenarios, each of the distances is different. D1 is different than D2, but from the starting point to this ending is a total distance. Okay? So D1 is not the same as D2, but there's a total distance from here to here. From here to here is the total distance. In each one of these scenarios, you're going to take D1 plus D2, and that equals the total distance. So D1 is not going to be the same as D2 in these scenarios. All three of these scenarios, you're going to use the same formula of D1 plus D2 equals the total distance. I can replace my D1 with a rate times time, R1 times T1. I can replace my distance, my second distance, with a rate times time. Since this is labeled with the 2, I will label these with the 2. This is labeled with the 1, I will label this with a subscript of 1. And those, adding those together equals a total distance. So this is the basic formula we will be using for all three of these scenarios in this lesson.